வணக்கம், இது சென்னை பிரதர்ஸ் சேனல். இன்னைக்கு என்ன பார்க்க போறோம்னா 10th ஸ்டாண்டர்ட்ல சமச்சீர் நியூ டெக்ஸ்ட் புக் சிலபஸ்ல ஃபர்ஸ்ட் சாப்டர் ரிலேஷன்ஸ் அண்ட் ஃபங்க்ஷன்ஸ் இதை பற்றி தான் நம்ம பார்க்க போகிறோம். Chapter 1 Relations and Functions. Mathematicians do not study objects, but relation between objects. Content to them is irrelevant. They are interested in forms only. Henry Poincare. Gottfried Wilhelm Leibniz, also known as von Leibniz, was a prominent German mathematician, philosopher, physicist, and inventor. He wrote extensively on 26 topics covering a wide range of subjects, among which were geology, medicine, biology, epidemiology, pathology, psychology, engineering, philosophy, sociology, ethics, history, politics, law, and music theory. In a manuscript, Leibniz used the word function to mean any quantity varying from point to point of a curve. Leibniz provided the foundation for formal logics and Boolean algebra, which are fundamental for modern-day computers. For all his remarkable discoveries and contribution in various fields, Leibniz is hailed as the father of applied science. Introduction. The notation of set provides the stimulus for learning high concepts in mathematics. A set is a collection of well-defined distinguishable objects. This means that a set is merely a collection of something which we may recognize. In this chapter, we try to extend the concept of set in two forms called relations and functions. For doing this, we need to first know about Cartesian products that can be defined between two non-empty sets. It is quite interesting to know that most of day-to-day situations can be represented mathematically either through a relation or a function. For example, the distance traveled by a vehicle in a given time can be represented as a function. The price of a commodity can be expressed as a function in terms of its demand. The area of polygon and volume of common objects like circle, right circular cone, right circular cylinder, sphere can be expressed as a function with one or more variables. In class 9, we have studied the concept of sets. We have also seen how to form new sets from the given set by taking union, intersection, and complementation. Now we are about to study a new set called Cartesian product for a given set A and B. Ordered pair. Observe the seating plan in an auditorium. To help orderly occupant to seat, tokens with numbers such as 1, 5, 7, 16, 3, 4, 10, 12, etc. are issued. The person who gets 410 will go to the row 4 and occupy the 10th seat. Thus, the first number denotes the row and the second number the seat. Which seat will a visitor with token 59 occupy? Can he go to 9th row and take 5th seat? Do 9, 5 and 5, 9 refer to the same location? No, certainly. What can you say about the token 2, 3, 6, 3 and 10, 3? This is one example where a pair of numbers written in a particular order precisely indicates a location. Such a numbered pair is called an ordered pair of numbers. This notation is skillfully used to mathematize the concept of relation. Cartesian product. Illustration 1. Let us consider the following two sets. A is a set of 3 vegetables and B is a set of 4 fruits. That is, A is a set of carrot, brinjal, lady's finger, and B is a set of apple, orange, grapes, and strawberry. What are the possible ways of choosing a vegetable with a fruit? Vegetable A and fruit B. We can select them in 12 different distinct pairs as given below. A carrot, an apple, carrot with an orange, carrot with a grape, carrot and strawberry, brinjal with an apple, brinjal with an orange, brinjal with a grape, brinjal with a strawberry, lady's finger with an apple, lady's finger with an orange, lady's finger with a grape, and a lady's finger with a strawberry. This collection represents the Cartesian product of a set of vegetables and set of fruits. Definition: if A and B are two non-empty sets, then the set of all ordered pairs small a, b such that A belongs to capital A and small b belongs to capital B is called the Cartesian product of A and B and is denoted by A cross B. Thus, A cross B is a set of A, B where A belongs to capital A and B belongs to capital B. Note: A cross B is a set of all possible ordered pair between the elements of A and B such that the first coordinate is an element of A and second coordinate is an element of B. B cross A is a set of all possible ordered pair between the elements of A and B such that the first coordinate is an element of B and the second coordinate is an element of A. If small a is equal to B, then A, B is equal to B, A. The Cartesian product is also referred as cross product. Illustration 2. Let A be a set of 1, 2, 3 and B a set of A and B. Write A cross B and B cross A. A cross B is equal to 1, 2, 3 cross a set of small a and small b. Now, it can be written as 1, A, 1, B, 2, A, 2, B, 3, A and 3, B. B cross A is a set of A, B cross 1, 2, 3. Now this set can be written as A, 1, A, 2, A, 3, B, 1, B, 2 and B, 3. As you can see, A cross B occupies this space and B cross A occupies this space. Note: in general, A cross B is not equal to B cross A, but number of A cross B is equal to number of B cross A. A cross B is equal to a null set if and only if A is equal to null or B is equal to null. If number of elements in A is equal to P and number of elements in B is equal to Q, then number of A cross B is equal to P into Q. Recall the standard infinite set. Natural numbers as this and whole numbers. Integers, rational numbers Real numbers, where q dash is a set of all irrational numbers. Illustration 3. For example, let A be a set of numbers in a interval 3, 5 and B a set of numbers in the interval 2, 3. Then the Cartesian product of A cross B corresponds to the rectangular region shown in the figure. It consists of all points x, y within the region. Progress check for any two non-empty set A and B. A cross B is called as Cartesian product of A and B. If number of A cross B is equal to 20 and number of A is equal to 5, then number of B is what? We already have learned in the note section, if number of A participant is equal to P and number of element in B is equal to Q, then number of A cross B is equal to P into Q. Now number of A cross B that is equal to 20, that is PQ, and number of A element is 5, that is equal to P. So we have to find the Q element. Q element is, if you substitute in this equation, you get the Q element as 4. If A is equal to minus 1, 1 and B is equal to minus 1, 1, then geometrically describe the set of points of A cross B. This is where it's get. If A, B are the line segment given by the interval minus 4, 3 and minus 2, 3 respectively, represent the Cartesian product of A and B. This is what you get. Note: the set of all points in a Cartesian plane can be viewed as a set of all ordered pairs x, y, where x, y are real numbers. In fact, R cross R is a set of all points which we call as the Cartesian plane. Example 1. If A is equal to 1, 3, 5 and B is equal to 2, 3, then find A cross B, B cross A. Is A cross B equals to B cross A? If not, why? Show the number of A cross B is equal to number of B cross A equal to number of element in A and number of element in B. Given that A is equal to 1, 3, 5 and B is equal to 2, 3. A cross B is nothing but 1, 2, 1, 3, 3, 2, 3, 3, 5, 2, 5, 3, and B cross A is equal to 2, 3 into A set, that is 1, 3, 5. Similarly, B cross A can be written as 2, 1, 2, 3, 2, 5, 3, 1, 3, 3 and 3, 5. From 1 and 2, we conclude that A cross B is not equal to B cross A because 1, 2 is not equal to 2, 1 and 1, 3 is not equal to 3, 1, etc. Third term, number of terms in A is equal to 3 and number of terms in B equals to 2. This is A is 3 and number of terms in B is equal to 2. From 1 and 2, we observe that number of A cross B equal to number of B cross A, that is equal to 6. That is 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5, 6. We see that number of A cross number of B is equal to 3 cross 2 cross, that is equal to 6. Hence, number of A cross B is equal to number of B cross A, that is equal to number of A into number of B element, that is equal to 6. Example 1.2. If A cross B is equal to 3, 2, 3, 4, 5, 2 and 5, 4, then find A and B. Solution A cross B is equal to 3, 2, 3, 4, 5, 2, 5, 4. We have A set of first coordinates of element A cross B. Therefore, first set is 3 and 5. B the set of two second coordinates of the element A cross B. Second coordinates are 2 and 4. Thus A is equal to a set of 3, 5 and B is a set of 4, 2, 4. Example 1.3. Let A is equal to x, where x varies from 1 to 4, and B, that is W, where it ranges from 0 to 2, and C, where x is as n, where x is greater than 3. Then verify A cross B union C is equal to A cross B union A cross C. For the solution, where A is equal to a set of 2, 3, where x ranges from 1 to 4, that is 2 and 3. For B, the value ranges from 0 equal to 2, that is 0 and 1. For C, it ranges from less than 3, that is 1, 2. Now, A cross B union C can be written as A cross B union A cross C. B union C, that is equal to B is 0, 1 union of C, that is 1, 2. So, union is 0, 1 and 2. A cross B union C, that is equal to A is 2, 3 cross B union C, which we have found as 0, 1, 2. Now, that is equal to 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2. A cross B is equal to A is 2, 3 and B is 0 and 1. Therefore, it is 2, 0, 2, 1, 3, 0, 3, 1. A cross C is equal to 2, 3, 1, cross 1, 2, where that is equal to 2 cross 2, 1, 2, 2, 3, 1, 3, 2. So A cross B union A cross C is equal to A cross B term union of A cross C term. So you get of 2, 0, 2, 1 and 2, 2 here, and 3, 1, 3, 1, 3, 0, 3, 1 and 3, 2. From 1 and 2, A cross B union C equal to A cross B union A cross C is verified. In second part, where A cross B intercept C, that is equal to A cross B intercept A cross C. A cross B intercept C is equal to A cross B intercept A cross C. B intercept C as B is 0, 1 intercept 1, 2 which is 1. A cross B intercept C is 2, 1, 3, 1. A cross B is 2, 0, 2, 1, 3, 0, 3, 1. A cross C is 2, 1, 2, 2, 3, 1, 3, 2. Now A cross B intercept A cross C is 2, 1 and 3, 1. From 3 and 4 we see that A cross B intercept C is equal to A cross B intercept A cross C is verified. Note, the above two verified properties are called distribution property of Cartesian product over union and intersection respectively. In fact, for any three set A, B, C, we have A cross B union C equal to A cross B union A cross C. Second one is A cross B intercept C equal to A cross B intercept A cross C. Cartesian product of three sets. If A, B, C are three non-empty sets, then the Cartesian product of three sets is a set of all possible ordered triplets given by A cross B cross C, that is A, B, C for all A as A, B as capital B and C as capital C. Illustration for geometrical understanding of Cartesian product of 2 and 3 sets. Let A be a set of 1, 0, 1, B 0, 1 and C 0, 1. A cross B forms this set representing A cross B in xy plane. We get a picture shown in 1.5. A cross B cross C is the which is represented is in three-dimensional shape. Representing the A cross B cross C in a XYZ plane, we get a picture shown in this plane. Thus A cross B represent vertices of the square in 2 dimension and A cross B cross C represent vertices for a cube in 3 dimension. Note, in general, Cartesian product of two non-empty sets provides a shape in 2 dimension and Cartesian product of three non-empty sets provides an object in 3 dimension. Exercise. Find A cross B, A cross A and B cross A, where A is given as 2, -2, 3 and B as 1, -4, which is solved for you here, and A equal to B equal to P, Q, which is here, and A equal to M, N, where B is a null set. This is solved here. இன்னைக்கு ஃபர்ஸ்ட் சாப்டர் உள்ள ரிலேஷன் அண்ட் ஃபங்க்ஷன்ஸ் பற்றி பார்த்தோம். இந்த சாப்டரில் உள்ள எக்ஸசைஸ் நம்ம நெக்ஸ்ட் வீடியோவில் ஃபுல்லாக பார்க்கலாம். தேங்க்யூ ஃபார் வாட்சிங் சென்னை பிரதர்ஸ்.